All right, so let's take some notes. All right, in 7.2, we will be solving simple exponential equations and inequality. An exponential equation has an exponential on one side, the other side, or both sides. So we're looking for b to the x equals b to the y's right now. Our b is going to have to be a number other than 1. As soon as we get b to the x equals b to the y, where the b's are the same, we can say the exponents have to be the same. So if we're really, really lucky, in our equation that we're given, we'll have the same base on both sides, which lets us just say that the exponents are going to be the same. So in one single step, x equals 3, and we're done. Even if it takes more than one step, we are still lucky if the bases on both sides are the same right away. It lets us set the exponents equal to each other. And so 1 minus x equals 5, and we can solve. Negative x equals 4, so x has to equal negative 4. But usually, they're going to require us to do a little more thinking than that. So our bases in example 3 do not match. So our first step is to make those bases match. And so we are taking 2 to the x equals 4 and changing the 4 into 2 to some power. 4 is 2 squared. So now our bases match, and we can set our exponents equal to each other. So x equals 2. Similarly, in number 3, we don't have the same base, so we're going to change 27 into something base 3. 27 is 3 to the third, so that the bases match, and we can set the exponents equal to each other. Thus, 2x minus 5 equals 3. And you're just going to solve, adding 5 to both sides, and then dividing by the 2. X equals 4. So, these are handy little tricks for being able to solve some equations. Equations get more complicated as we go on, so we need to just be able to work with that. When we get 4 to the 2x squared plus 2x equals 8, we have to recognize that 8 isn't 4 to an easy power. So instead of changing 8 into 4 to some power, we're going to change both sides. We're going to change the 4 on the left-hand side into 2 squared, which means we're multiplying powers times powers. And we're going to change the 8 into also a 2, because 8 is 2 cubed. That way we do have the same bases, and we can set the exponents equal to each other. So 4x squared plus 4x has to equal 3. We have x squared and x in the same equation, so we're going to set it equal to 0 so that we can factor, use the quadratic formula, or complete the square, whichever your favorite thing is to do in the world. I'm going to get my pen to work. I'm going to factor. Let's see, 2x times 2x is 4x, and 3 times 1 is 3. I want it to be a negative, so I need a positive and a negative. My inside term is going to be negative 2x plus 6x, which is 4x in the middle. So I have guessed, I have checked, and I am moving on. The zero product property says if two things multiply together to equal 0, either one of them equals 0 or the other one does. Letting us finish solving this problem, we get two answers, either x equals negative 3/2 or x equals 1/2. In example 6, we have 5 to the x plus 1 equals 1 over 125. We're going to have to use all of our exponent rules as we work towards finding the common base in these problems. So 125 is 5 cubed. When you have 1 over a number, that is really a negative exponent. Then you have the same base, so you can set the exponents equal to each other. So x plus 1 equals negative 3, and x equals negative 4. Eight to the x minus 2 equals the square root of 8. 8 x minus 2, we have a nice 8 inside of there. We just have to remember that radicals are fractional exponents so that we have the same base, and we can set the exponents equal to each other. X minus 2 equals 1/2. And so x equals, adding 2 to 1/2, you're going to find common denominators. X equals 5/2. And let's do one more before we switch videos. 3 to the x equals negative 27. So we can say that negative 27 is negative 3 cubed. Or we could say that 3 to the x equals negative 3 cubed, but either way, our bases are not the same. 3 is not the same as negative 3. If you think about this, 3 to the x looks like the graph of the exponential, y equals 3 to the x. Where is that going to be equal to negative 27? Are those two things ever going to intersect each other? No. It is an impossibility. There are no solutions. So we really have to be able to think through all our properties. We have to know what negatives mean. Where they are in the equation tells us different things. Negatives in the exponents versus negatives on the base versus negatives in front of the base. When can we combine them? When can we not combine them? All of these things are things that you do need to think about as a young fledgling mathematician. Let's go to the next video.